Next slide, please. Geothermal energy harnesses the Earth's internal heat for electricity generation, heating, and industrial use. It's a reliable and sustainable energy source that operates independently of the weather conditions. Globally, countries like US, Indonesia, and Philippines are leaders in geothermal power, contributing to a cleaner energy mix and reducing greenhouse gas emissions. Turkey, with its rich geothermal resources primarily in western Anatolia, has become a significant player in this sector. The country's investment in geothermal power plants and heating systems supports both the national electricity grid and various applications, including greenhouse and residential heating. As the world moves towards sustainable energy solutions, geothermal energy stands out for its potential to provide clean, constant, and reliable power.
Hello, everyone. I briefly talk about geothermal energy in Turkey and the world. In Turkey, geothermal energy holds a key position. The country ranks first in Europe and fourth globally. Due to its location on tectonic fault lines, as of 2023, Turkey's installed capacity reached 1,710 megawatts, showing rapid growth over the last decade. It is widely used for electricity production, district heating, greenhouse heating, and in tourism, with attractions like Pamukkale and Afyon's hot springs. Economically, geothermal energy creates jobs, reduces reliance on fossil fuels, and contributes to energy independence. The Aegean region leads the way with additional potential in central Anatolia. Globally, the United States, Indonesia, and the Philippines lead in geothermal energy, with Turkey's ranking fourth. Total global installed capacity is 16.3 gigawatts, and innovations like enhanced geothermal systems are expanding its applications. While challenges such as high cost remain, Turkey's government support and untapped potential provide significant growth opportunities. In conclusion, geothermal energy is a sustainable and reliable resource for Turkey and the world, contributing to a greener future. Thank you.
Hi, I'm Kaan. Today I will talk about the usage areas of geothermal energy. The usage areas are very diverse in Turkey and around the world. You can see the usage rates in the world on the graph. The main areas where energy is used are heat pumps, district heating, tourism, as well as agricultural areas and industrial use. Heating is the one heading. Geothermal energy is widely used in heating and cooling systems. Also, the resources provide solutions for some engineering applications. For example, they can be used in ground to prevent icing on steep slopes and airports runways. Another heading is tourism. The rich minerals of geothermal and water is also very important for thermal tourism and health sector. The best example in this field is Japan. They attract 15 million visitors annually with these thermal sources. In Turkey, regions like Denizli, Pamukkale, Afyon, and Yalova host local and foreign tourists in this sector. Agriculture is another heading. Integrating geothermal energy into agriculture with heat pumps, greenhouse can achieve 68% energy savings with zero fossil fuel consumption. Another usage area is industrial application is mainly used for electricity production and dry ice production in this sector. Ali Kemal will continue the presentation.
It is really important environmental impacts and problems of the geothermal energy. 4.1 Water quality and pollution. Geothermal fluids contain heavy metals and toxic compounds, can contaminate surface or groundwater, affecting quality. Impacts increasing the salinity, loss of biodiversity. Next. Air pollution, hydrogen sulfide emissions create odor and toxicity. Impacts respiratory issues, deterioration of the air quality. Example, Iceland village affected by hydrogen sulfide emissions. Geothermal plants require extensive land use. Impacts destruction of the sensitive ecosystem, flora and fauna. Example, Philippines. Fluid injection can trigger micro seismic activities. Extraction may lead to land subsidence. Impacts infrastructure damage, reduce agricultural productivity. Improper disposal of geothermal fluids and solids is a threat. Impacts soil contamination, chemical accumulation. On the other hand, we are now going to see mitigation, water quality. Reinjection, pumping fluids back to prevent contamination. Example, Iceland reinjection widely applied. Chemical treatment, removing toxin compounds with reverse osmosis. Gas collection systems capture the threat, hydrogen sulfide emission. Example, USA Optimum system, energy affecting tech, binary cycle reduces gas emissions. Site election, avoid sensitive ecosystems, restoration, rehabilitate used land, monitoring, install seismic risk warning systems, control injection, manage fluid injection pressure. And the last one, recycling, recover silica and byproducts for industrial use. Example, silica used in construction. Protocols manage waste per international standards.
Hello everyone, my name is Mazen. Today I'm going to talk about the geothermal heat pumps or ground source heat pumps. Transfer heat to and from the ground, unlike traditional HVAC systems, which rely on fossil fuels or electricity from non-renewable source. Geothermal systems harness the Earth's natural heat. Next. Today, now I'm gonna talk about how it works. In heating mode, a geothermal heat pump extracts heat from the ground. To this heat is then amplified and transferred into the building. Conversely, in cooling mode, the system removes heat from the building and deposits it back into the ground. Next. Efficiency and savings. Geothermal heat pumps are incredibly efficient. For every unit of electricity used, to 3 to 5 units of heat, translating to 300% to 500% efficiency. Compared to traditional systems that typically operate around 80% to 95% efficiency. Homeowners can reduce their heating and cooling bills by 30% to 70%, for instance. If a typical household spends $2,000 annually on energy, switching to a geothermal system could save them between $600 to $1,400 each year. In installation and lifespan, initial installation costs range from $10,000 to $30,000, influenced by the system size and ground loop configuration. The average payback period is 5 to 10 years due to the energy saving and potential tax credits. We have 3 types of ground loops. One, closed loop systems. We have horizontal loops, cost-effective for new constructions with available land, installed 4 to 6 feet deep. Vertical loops suitable for limited space, more expensive, drilled to 100 to 400 feet deep. Pond or lake loops utilize nearby water bodies for heat exchange, cost effective if conditions allow. We have another loop, open loop system, which uses the groundwater from a well as a heat exchange medium, requiring a sufficient water supply and regularity compliance. In lifespan consideration, ground loops extremely durable, lasting 50 years or more. Heat pumps lifespan of 20 to 25 years, similar to traditional HVAC systems, with regular maintenance extending performance. Investing in a geothermal heat pump system is a commitment to long-term energy efficiency and sustainability, offering significant returns over time through reduced energy costs and environmental impact.
To sum up, geothermal energy is a sustainable and reliable renewable energy source with the potential to significantly contribute to the global energy mix. While it currently meets a small fraction of the world's energy demand, technological advancements and cost reduction could see its role increase substantially by 2050. In Turkey, geothermal energy is a key player in the renewable energy sector. With its significant geothermal resources, particularly in Western Anatolia, Turkey is a global leader in both geothermal heating and electricity generation. Continued exploration and development efforts in the country will further harness this renewable resource, contributing to Turkey's energy security and sustainability goals. Overall, geothermal energy offers a promising path towards a cleaner, more sustainable energy future both globally and in Turkey.